From so-called WIMPs to the elusive MACHOS, there are a number of particles once thought to be key players in the ongoing search for dark matter. But scientists have yet to find WIMPs, and recent studies have essentially killed off the latter. New evidence, however, suggests there may be another type of particle to consider. Mysterious particles known as SIMPS have begun to gain support among physicists, who suspect they may interact strongly with themselves, but not with others. Dark matter makes up roughly 27% of the universe, and is invisible because it does not reflect light. It cannot be seen directly with telescopes, but astronomers know it to be out there because of the gravitational effects it has on the matter we can see. The European Space Agency says, "Shine a torch in a completely dark room, and you will see only what the torch illuminates." That does not mean that the room around you does not exist. Similarly, we know dark matter exists, but have never observed it directly. Scientists are fairly sure it exists and is crucial to the universe, but they do not know what it looks like or where to find it. Dark matter is thought to be the glue that holds the galaxies together, while just 5% the universe consists of known materials such as atoms and subatomic particles. Researchers have looked for weakly interacting massive particles, WIMPs, for decades, to no avail, explains theoretical physicist Hitoshi Murayama, a professor of physics and director of the Kavli Institute for the Physics and Mathematics of the Universe in Japan, and faculty senior scientist at Lawrence Berkeley National Laboratory. These are thought to be roughly 100 times heavier than a proton, but rarely interact with each other. Instead, it's thought that they interact more frequently with normal matter through gravity. MACHOS, on the other hand, are said to be massive compact halo objects, or normal matter that's too dim to see. This could include failed stars and black holes.But. A recent survey of the Andromeda galaxy by the Subaru Telescope ruled out the possibility of significant undiscovered black holes, the researchers says. SIMPS, however, or strongly interacting massive particles, could leave fingerprints on normal matter, despite mostly interacting with themselves, the researchers says. According to Murayama, 4 colliding galaxies in the Abell 3827 may exhibit such fingerprints. There, interactions between dark matter in each of the galaxies could slow the merger of the dark matter, but not the normal. One way to understand why the dark matter is lagging behind the luminous matter is that the dark matter particles actually have finite size. They scatter against each other, so when they want to move toward the rest of the system they get pushed back, Murayama says. This would explain the observation. That is the kind of thing predicted by my theory of dark matter being a bound state of new kind of quarks. According to Murayama, the existence of SIMPS could also help to solve a major issue in the WIMP theory, in which they're unable to explain the distribution of dark matter in small galaxies. Scientists plan to launch experiments to look for SIMPS using ground-based instruments, such as CERN's Large Hadron Collider and the International Linear Collider in Japan. There has been this long-standing puzzle. If you look at dwarf galaxies, which are very small with rather few stars, they are really dominated by dark matter, Murayama said. And if you go through numerical simulations of how dark matter clumps together, they always predict that there is a huge concentration towards the center. A cusp.But observations seem to suggest that concentration is flatter, a core instead of a cusp. The core-cusp problem has been considered one of the major issues with dark matter that doesn't interact other than by gravity. But if dark matter has a finite size, like a SIMP, the particles can go clink and disperse themselves, and that would actually flatten out the mass profile toward the center. That is another piece of evidence for this kind of theoretical idea. There are numerous particles in the running as dark matter candidates. The team is also looking for a hypothetical particle called the action.The new interest in SIMPS doesn't mean the others should no longer be considered, the researcher explains. But it may prove a better candidate. Of course we shouldn't abandon looking for WIMPs, Murayama said, but the experimental limits are getting really important. Once you get to the level of measurement where we will be in the near future, even neutrinos end up being a background to the experiment, which is unimaginable. Let's stop and think about it again.